Okay, let's take a look at the assignment that's due today. This is what it looks like. Here is the values for the heat of fusion, heat of vaporization values. Be careful because the joules per kilogram instead of joules per gram. I guess we're mostly looking at water today. Here's the graph. You can see when water is a solid ice, uh, it will warm up until it starts to melt, and we get the phase change. Notice there's no temperature change. Okay, and then the liquid heats up, starts to become steam, it vaporizes. No temperature change there either. And then if you could capture all the gas and you could heat it up and then keep heating it, and then after, from E to F, after that, it would become a plasma if you keep adding heat, but that's not on the graph. All right, here's the heat of fusion equation. Notice how for water, for the heat of fusion, it says 334 joules per gram. And notice over here, it is in joules per kilogram, so it's a little different, so you have to watch out for that. It'll be the same number for the fusion, but you have to convert the kilograms to grams or grams to kilograms. And notice here's the other equation for vaporization. They look very similar, but you use the vaporization values right here, right, instead of the fusion values. Let's take a look at the assignment. The first one, how much heat must be added? So you have a solid ice and you're just melting it. So there's no temperature change. So you should just use the fusion equation. Number two, how much heat is lost when 5,000 grams of steam condenses? And so that's a vaporization problem. But notice that there's no temperature change, but you're condensing. You should use the vaporization equation. And let's take a look at number three. How much heat is lost when steam condenses to water, and then that water cools down another 50 degrees? Well, you have to be careful. You have to use both equations. You have to use the vaporization equation for converting the steam to liquid, and then after it's all liquid, it'll start to cool down. You have to use this equation. So you have like a Q1 and Q2. You have to add them both up. Let's take a look. How much heat is needed to change ice into water? Okay, so no temperature change there. You can get away with just using the equation for fusion, because you go from ice to water. Okay, but let's go to number five here. Look at number five. How much total heat is needed to change the ice to water from 0 to 0? And then you're going to heat the water up to another 50 degrees. So you have to have both heat equations. So let's take a look at, I guess let's start with the first one. How much heat is needed to add? So this is just ice, and it is changing to water, so no temperature change. So we don't have to use Q equals MC delta T. So for number one, we could just say Q equals fusion, right? So what did number one say? 500 grams of ice. Okay, so I know the mass, like 500 grams. Okay, if I need to convert that to kilograms, divide by 1,000, and that's that's a half a kilogram. All right, so I could use either one. Now, let's see. Look at the value for LF for latent heat of water. It's 334 joules per gram. Okay, so both in grams. But if I use the one from the data table, it's 3.3 times 10 to the fifth, and that is joules per kilogram. And looks like the joules per kilogram one, that one got rounded a little bit, but we should get the same answer as far as joules. Okay, so either case. So let's see, 500 times 334 should be a little different because I think because of the 334 versus the 3.3. Okay, now the 0.5 times 10 to the fifth. Actually, 0.5 times 3.3 times 10 to the fifth. So let me bring this one out. 1, 2, 3, 4, 5. So I'm going to call it 330000 times 0.5. Okay, and I ended up with 165,000 joules. So it looks like it's a little bit different because of the rounding, but that's how the first one goes. When I look at number 3, I got to be careful because remember you're finding steam condensing into water, so it's vaporization, but also you have to add that heat to the temperature change. And so just remember, go ahead and find this one using the vaporization equation, which is very similar to the fusion equation, but make sure on the data table you use the vaporization values. But over here we have to also, it's like 5,000 kilograms. Be careful. We have to convert that to grams. Okay, and the specific heat of water, remember, it was like 4.184 times 10, joules, grams degrees Celsius. Okay, times the, get rid of that, times the temperature change, and it went, the final temperature was 50, right? And it was up at 100. Okay, and we have to convert this. You have to multiply, get rid of the kilograms. You want to multiply by 1,000 to convert to grams. So this will be, this is really like 5,000 times 10 to the 3 times 4.184 times 50 minus 100. Now notice this is going to give you a negative, but that's okay. And this one over here, this the heat lost, this one's a negative also. All right, so you're going to get a negative here and a negative here, so they're both going to be negatives. You're going to end up with a total heat lost as this stuff cools off. Okay, that's all I have for now. I'll talk to you later and get with the next video.